Lesson number 2 is the subsets of the real number system. If you notice, we have our sets of numbers here, and I know they're small, but if you see what we have here, we have different types of numbers. The square root of 25 is 5. Here, the next thing that we have here is the square root of 196 we have is 14. We also have some decimals, we have fractions. I'm going to turn them all into different types of numbers here. We have 7 squared, which is 49. We have 1/9, which is as a decimal 0.01 repeating. We have 0/8, which is 0. The square root of 55 is an irrational number, and it is 7.416198, and it continues to repeat. Then we have the square root of 17, which is 4.1231. 0.56, and that also repeats. Then we have negative 1/5, which is negative 0.2. Next we have 1/4, which is 0.25. Next we have pi, which is 3.14159. 26, and that continues to repeat. The square root of 144 is 12. Then we have 16/2, which is 8. The square root of 72 is 8.4. 852. 81. And that repeats. Then we have 44 to the 0 power, and remember, anything to the 0 power is 1. So the next thing that we're going to do is, using the following tables, we're going to determine the similarities and differences that we notice among the different types of numbers. And we can use the calculator for that. So our similarities is that they're all numbers. Our differences is we have different types. One, we have different representations. So for example, we have whole numbers. We have negatives. We have decimals. We have fractions. We have square roots. And we have squares. We have that some decimals repeat. Some terminate. Some go on forever. some square roots equal an integer, and some equal a decimal that does not terminate or repeat. Some fractions equal whole numbers some equal terminating decimals some equal repeating decimals. Next, we have some examples of our different types of numbers. So from those numbers that we have out there, we have our natural numbers, which are numbers such as 16 over 2, square root of 144, square root of 25, $89, our whole numbers are then 0, 44 to the 0 power, $7,890,123. Numbers such as 12 over 3, and numbers like that. Integers are any numbers and their opposites, as long as they are whole numbers. Again, no fractions, no decimals, okay? Such that they can be negative or positive, okay? So we can include then -4. We can include 38. We can include numbers such as 5,000. We can include numbers such as 25 over 5. We can include -46 and numbers such as that. Rational numbers are any numbers that can be written as a fraction, such as, again, we can have numbers that can be written as -2/3, 12 over 6, 2, 1/4, 6,000, 7 squared, 7 squared can also be here because it simplifies to 49. 1/9. Irrational numbers are numbers that never end, never repeat. Square root of 17, pi, square root of 55, square root of 23, and so on. Now, next. So the real number system, by definition, the real numbers are all the numbers on the number line, okay? So our subset, by definition, okay? Rational numbers, that is like our biggest umbrella. All numbers are rational numbers. They're either rational numbers or we have a real number system. That's our real number system. And then they're divided into two things, rational numbers or irrational numbers. So we have rational numbers that are a number that can be written as a fraction, where a and b are integers and b does not equal 0. You can have b in the denominator. And it may be expressed as a fraction, a terminating decimal, or a repeating decimal, okay? Or it can be an irrational number, and this subset of the real numbers cannot be written as the quotient of two integers, and the decimal form neither terminates nor repeats, okay? And then underneath that rational umbrella, you have integers. So an integer is any whole number, its opposite, and 0. So in other words, like this. Then we have whole numbers. Numbers that start at 0 and go 1, 2, 3, 4, 5, and so on. Then we have our natural numbers. natural numbers or counting numbers. This subset includes the whole numbers from 1 and upwards. In other words, how do you count? 1, 2, 3, 4, 5. The set begins where you would begin if counting. 0 is not included. Okay? So they're whole numbers. Now, the one thing that you want to understand is we can go from the inside out, but not the outside in. So if it's a natural number, it would be a natural, a whole, integer, and rational. But just because it's rational does not mean that it's an integer, a whole, or a natural number. Okay? So now, let's classify some of these numbers by determining all the sets that the numbers to which they belong. So, for example, 5. 5 is a natural number. Therefore, because it's natural, it's also a whole number, an integer, and a rational number. Because it's got to go from the inside out. If it's natural, it's got to be the others. 0.6666666. It's a decimal. It can be written, if you remember, 0.6 repeating is a fraction, which is 2/3. It is a rational number, so it is only a rational number. Negative is the square root of 25. Because the negative is on the outside, it stays there. The square root of 25 is 5. So our number is -5. Therefore, it is an integer. And it is rational. So again, we go from the inside to the outside. Square root of 11 is an irrational number. And that's all it can be. 5 4/5, again, is a rational number because it can be written as a fraction and it has that fraction with it. So it is a rational number. You can go from the inside out, but not the outside in. This ends our lesson.